All right, today you are going to be learning about how to make measurements and how to make measurements with the correct precision. So why does this matter? Let's say that you're driving in Wasito City, where the speed limit is 30 miles an hour. I don't know if I pronounced that name right, so it's okay if you judge me. But let's say that the speed limit is 30 miles per hour. Will you get a ticket if you're driving a little over the speed limit, like 31 miles an hour or even 35 miles per hour? Not likely. Your car's speedometer is pretty imprecise, meaning that it only rounds to the nearest whole number. So when you're reading your speed limit, you don't actually know exactly how fast you're going, whereas a cop's radar gun is much more precise. This is why one of the first questions a police officer might ask you when they pull you over is, how fast were you going? It's actually been successfully argued in the court of law that if you don't know the precision of your speed, you get some leeway with breaking the speed limit, which is why we have a lot of leeway with our speed limit. Usually if you're within 5 miles per hour of the speed limit, you're given some leeway as far as tickets go. So significant figures are all of the certain digits in a measurement as well as one uncertain digit in a measurement. Your last digit in a measurement is always going to be the uncertain one because it's the one that is estimated. Now, most of the time, insignificant digits aren't even reported in the measurement. So if we look at the two rulers that we have on the left, they're different based off of the number of tick marks that they have. This affects their precision. So if I were to take the same exact measurement with these two different rulers, I would actually get different measurements. With the top ruler, I would have a measurement that consists of what I know for certain and what I know that's uncertain. So I know for certain that this blue dotted line is at least 2. How do I know that? It comes past the number 2 tick mark. I also know that it's at least 2.5. How do I know that it's at least 2.5? Because it comes past the 2.5 tick mark. So 2.5 are my certain digits. My uncertain digit is what comes past 2.5, the part that I have to estimate. So it looks like this blue dotted line is right between 2.5 and 2.6. So I could estimate that this measurement is 2.55. That 0.55 is my uncertain digit because I had to estimate that part. So if I were to count the number of significant figures that are in this measurement, I would count how many certain digits I have and how many uncertain digits I have. So since there are 2 certain digits and 1 uncertain digit, this measurement has a total of 3 significant figures. Now with the ruler on the bottom, what's going to be different? Well, this blue dotted line I know is at least 2 because it comes past the second tick mark. But beyond that, I'm not entirely sure because there aren't tick marks to help guide me. So everything I make in my measurement from here on out is just going to be an estimate. So it looks like this blue dotted line is about halfway between 2 and 3. So I could reasonably estimate that this is 2.5. Now this measurement only has 1 certain digit and 1 uncertain digit. So it only has a total of 2 significant figures. So if I compare my number of significant figures, it seems like the more significant figures you have in a measurement, the more precise your measuring tool is, which makes sense. The top ruler has more tick marks, allowing me to be more precise in my measurement, which allows me to have more significant figures. Now with either of these rulers, it would be impossible to measure something like 2.54799999. Why? Because all of these extra digits at the end are insignificant. They're insignificant specifically because I don't have enough tick marks for me to accurately estimate that far out. So insignificant digits are digits that you can say because you feel like saying that that's the measurement, but they're entirely insignificant because your measuring tool just can't measure that precisely. So let's move on. Let's do an example of measuring the length of this ant with 2 different rulers of varying precision. We'll start with the one on the left. Now, when you're making a measurement, you should always consider, what do I know for certain and what do I know that's uncertain? So for this ant right here, I know for certain that he's at least 1 centimeter long. I know that for certain. Beyond that, I'm not entirely sure because there aren't tick marks to help guide me. So I'm just going to draw a dotted line to help me estimate. This ant looks like he's maybe at 1.2. Oops, I didn't mean to erase that. It looks like he's maybe at 1.2. So the 1 in my measurement is certain, but the 0.2 is uncertain. Now I'm going to ask that you also color code your measurements because you will need to be able to identify certain and uncertain digits in a measurement. So let's move on to the other ruler on the right. I've got the same ant with a ruler that's got more tick marks. So I'm going to figure out, what do I know for sure? So I know for sure that this ant is at least 1 tick mark long, or 1 centimeter long. I'm going to have to estimate with a blue dotted line. It looks like it comes just past that 1.2 tick mark, but I'm going to have to estimate it. It looks like it comes right past that 1.2 tick mark. So I know for sure he's 1.2. How far past 1.2 does this ant measure? It looks like it's barely past 1.2. So I'm going to estimate that this ant is 1.21. Now, some of you might be looking at my drawing as I'm looking at it now, and it looks like my dotted line is kind of angled, don't you think? Let me try drawing this again. Let me try drawing my dotted line straight. It's a little bit better. It looks like the ant actually might be falling right on the 1.2 tick mark. I got to start over. The ant is falling right on the 1.2 tick mark. How would I write that measurement? Well, I know for sure that he's 1 centimeter. And since he's on the 1.2 tick mark, I guess I know for sure that he's 1.2 centimeters long. So this is a certain digit. But I also need an uncertain digit. I need an estimate. Now, if I'm guessing that he's falling on the 1.2 tick mark, which I'm guessing based off of that blue dotted line, then my estimated digit is going to be 0. Let me explain why. When you are estimating that something is right on the tick mark, your uncertain digit is going to be 0. What that's telling the reader of your measurement is you're saying, I think that this ant fell right on 1.2. He wasn't shorter than 1.2 centimeters, he wasn't at 1.19, and he wasn't longer than 1.2 centimeters at 1.21. I think he was right at 1.2. So my uncertain digit is that 0, because that's what I'm guessing, is that he's right at 1.2. So let's try another one. So we've got 2 different rulers. We're going to measure where the arrow is pointing with those 2 different rulers. So I'm going to do this by identifying my certain digits and then my uncertain digits. So this arrow I know is at least 0.3. Now these tick marks in between 0.3 and 0.4, I need to know what increments they're going by. So if I were to draw a number line and expand this, 0.3, and I'm trying to get all the way to 0.4. My next tick mark would be 0.31, and then 0.32, and then 0.33, and then 0.34, and then 0.35, and then 0.36. You kind of get the point. I'd be going up by hundredths is the point I'm trying to make. And I'd have 10 tick marks in between 0.3 and 0.4. So this tick mark, I'm going to mark in yellow, is representing 0.36. So what do I know for certain in my measurement? I know that this arrow is at least 0.36 units. My uncertainty is going to come from how much farther past 1.36 it is. And it looks like it's right in between. If I were to look on my expanded ruler, it looks like it's right in between 0.36 and 0.37. So I could estimate that it's maybe 0.365. So if I were to color code my measurement. 0.36 is what I know for certain, and this 5 is my uncertain digit. So let's try the same measurement with the ruler on the right. So we know for sure that this arrow is 0.3. But beyond that, we don't really know because we don't have any other tick marks. So all we can say for certain is that this arrow is 0.3 units. After that, I have to estimate. So it looks like this arrow is past halfway. I would estimate that it's closer to 0.4 than it is to halfway. So I would want to say that this is maybe 0.37. And since I'm having to estimate this 7, that is my uncertain digit. So I'm going to have you guys try the next one. Go ahead and pause the video when you're ready to check your answer. Unpause. All right, I'm assuming if you're watching this, you are ready to check your answer. I'm going to start with the ruler on the left and figure out, what do I know for sure? Well, I know for sure that the arrow is 0.02 units. After that, things start to get tricky. I'm going to start marking my arrow with the blue dotted line. They're starting to get tricky because it looks like that blue arrow is falling right on a tick mark. So I got to figure out, first of all, what do these tick marks even represent? So if I were to expand my number line so that I could write this out, talking about the tick marks between 0.02 and 0.03. So there are quite a few tick marks. If I'm going from 0.02 to 0.03, my increments must be going up by the thousandths place. I must be going from 0.02 to 0.021 to 0.022 to 0.023, 0.024, so on and so forth. So this middle way mark is 0.025, and the mark that I just drew my blue dotted line over, that must be 0.026. So I'm pretty sure that this is at least 0.026. It's falling right on the tick mark. So that's what I know for certain. My estimated digit is going to tell me if I think it's right on the tick mark or just past the tick mark. If it's just past the tick mark, I would say something like 0.021. But I don't think it's just past the tick mark. I think it's right on the tick mark. So our uncertain digit when we're estimating on the tick mark is always 0. I'm going to make that note again, like I did on the last example. When we think a measurement is on the tick mark, your uncertain digit is just going to be 0. Let's try the next one. I know for certain that this measurement is 0.02. But after that, I'm not sure because there aren't any tick marks. So I'm going to mark with a blue dotted line to help me figure out where this is. It looks like it's just past halfway. Just past halfway. So I'm going to say 0.026 because I don't think it's at 0.025. I think it's just past halfway. So the 0.02 is my certain digit and my 6 is uncertain. Go ahead and try this last one without me. All right, if you're listening to this, I'm assuming you've already tried it. Let's start with the graduated cylinder on the left. When we're making a measurement with a graduated cylinder, we might see that the liquid is curved, making a meniscus. You may have heard of the meniscus in your knee. It's the same exact shape as this curve right here. When we're trying to make a measurement of a meniscus, we're always going to take the measurement at the bottom of the curve. So right there. So it looks like I know for certain that this measurement is 60. I know it's at least 60. But beyond that, I can't be sure. They gave me a halfway mark, but it's not a halfway. So I guess I would probably estimate that it's in between 60 and 70. So that halfway mark is what? This line is 65, so it's just not quite at 65. I guess I'd say 64. 64. So I'm certain that it's 60, but I'm uncertain that it's 64 because I guess it could be 63. Let's try the next one. We know for certain that this measurement is at least 60, and it looks like it's also on the 64 tick mark. So we know for sure that it's 64. Our uncertain digit is going to come from whether or not it's right on the tick mark or just past the tick mark. So this to me looks like it's right on the tick mark. I don't think it's just past it. So if it's right on the tick mark, my uncertain digit is going to be 0. And that's how I tell the reader this is right at the 64th tick mark. No more, no less. So let's move on. When we're looking at a measurement, we can tell how precise it is by counting the number of significant figures. So we need to know how to correctly do that. There are 3 rules to counting significant figures. The first one is that leading zeros never count. The second one is that ending zeros only count if there's a decimal. And the last rule is that all numbers that aren't leading or ending zeros always count. So let's look at some examples for rule number 1. Leading zeros never count. If I had the number 12 and I wanted to count the number of significant figures, leading zeros never count. There are no leading zeros in this number. So 1 and 2 would be significant. So this has 2 significant figures. But let's say I had 0, 1, 2. It's still the number 12, but it's got a leading 0 in front. Well, I know 1 and 2 are going to count, but leading zeros never count. So this measurement still has 2 significant figures. But what if I had a decimal, 0.0012? Well, I know that 1 and 2 are going to count, and all of these zeros are leading zeros. They're in the front of the number, so they don't count. So this measurement also only has 2 significant figures. Now let's talk about ending zeros. Ending zeros only count if there's a decimal. So let's look at a measurement, 120. I know that 1 is significant, I know that 2 is significant, but this 0 is an ending 0. Now ending zeros only count if there's a decimal, and there is no decimal written in this number. So that ending 0 is insignificant. So this measurement has 2 significant figures. Moving on, let's say it was 120.0. I know that 1 and 2 are significant, but these zeros are ending zeros. However, they wrote a decimal in the number, so they count. So I have 4 significant figures in this measurement. Last one, let's say it was 12,000 and the reader or the writer put a decimal at the end of the number. That's specific because you don't need that decimal for the value of the number, but you do need it for the measurement. 1 and 2 are significant, and these ending zeros are now significant because there's a decimal in the number. So we have 5 significant figures. Last rule, rule number 3. All numbers that aren't leading or ending zeros always count. So 7 and 1 definitely count. Since these zeros are not leading or ending zeros, they're going to always count. So we have 4 significant figures. My next one, I know that 7 and 1 are going to count. I know that my middle zeros count, but this ending 0 is only going to count if there's a decimal, and there is no decimal in this number, so still only 4 significant figures. Now my last one, 7 and 1 count, my middle zeros count, and there's a decimal, so that ending 0 also counts. So there are 5 significant figures. I'm going to have you guys practice using your rules on these, and when you're ready to check your answers, unpause the video. All right, I'm assuming if you're listening to this, that means you tried these and you are ready to check your answer. So let's start with 897. 8, 9, and 7 are all whole numbers, so they count. 3 significant figures. 7,009. The 7 and the 9 definitely count, and my middle zeros also count, so I have 4 significant figures. 2,530. I know the 2, 5, and 3 count, and my ending 0 only counts if there's a decimal, and there is no decimal, so it does not count. 3 significant figures. 8,500,200. I know the 8, 5, and 2 count. I know that these middle zeros count, but my ending zeros don't count if there's no decimal. So this has 5 significant figures. 0.00034. I know the 3 and the 4 count, but now I got all these leading zeros. Luckily for me, leading zeros never count. I don't even have to think about it. So this only has 2 significant figures. The next one, 8 and 4 count. My leading zeros never count, and my ending zero only counts if there's a decimal. And technically, yeah, there's a decimal, so it counts. 3 significant figures. My next one, I know 5 and 8 count. I know a middle zero counts. Leading zeros never count, and ending zeros only count if there's a decimal, which there is. So this has 5 significant figures. 7,200. 7 and 2 count. My ending zeros count because there's a decimal. 4 significant figures. 5.20. 5 and 2 count. This 0 is an ending zero, but it counts because there's a decimal. 3 significant figures. And last but not least, 830.00. The 8 and the 3 count, and these ending zeros only count if there's a decimal, which there is. 5 significant figures. So let's go ahead and pause for here and go ahead and